Welcome to AMS on the Air. I'm Dakota Smith.
I'm Jeff Rosenfeld.
And I am Irene Sands. We're here to podcast all things weather, water, and climate.
So it's from that probabilistic perspective that we hope we're providing better information. That's the real advantage of these application models, is it really filters it down to what's important.
Thanks for listening to another episode of AMS on the Air, the official podcast of the American Meteorological Society. Today we have a special episode that features an interview that focuses on the Journal of Weather and Forecasting. Specifically, this interview will focus on a recently published paper titled Seasonal Forecasting of Wind in Waves in the North Atlantic using a Grand Multi-Model Ensemble. This paper was written by Ray Bell and Ben Kirtman, both of University of Miami. Featured in this interview will be Ben Kirtman, one of the authors of this paper, Brian Ancell of Texas Tech University, acting editor in charge of this paper, and Gary Lackmann of North Carolina State University, who is the chief editor of the Journal of Weather and Forecasting. This interview begins with Gary discussing the importance of this journal and why this paper fits perfectly in it. Jeff then moderates the roundtable between Ben, Brian, and Gary. Enjoy.
There's something that's been known as the Valley of Death, which is basically the separation between the research communities and sort of the applied operational communities. And this is not just in meteorology, but in a lot of different fields. And this is certainly true in the atmospheric sciences, where you have researchers that are doing work and publishing it. And then there's operational forecasters that are struggling with different challenges. And there had been sort of a lack of communication between those communities. So back in 1986, now over 30 years ago, the AMS sponsored and formed this journal, Weather and Forecasting, that was really designed to bridge the gap between the operational community and the research community, and sort of present a forum for these different parts of the community to interact. And one of the other goals of the journal is to provide a medium for the presentation of new forecasting and analysis methods and techniques. So those are sort of the traditional communities that the journal has served: the operational forecasting community, the numerical modeling community, and observationalists. Really anyone who's studying forecasting and methods for improving modeling and forecasting has been served by this journal. Now, there's a few areas that are sort of new to the journal that I think are growing, and one of those is seasonal and subseasonal prediction. This is sort of a new scientific frontier, obviously very challenging to make predictions at these longer timescales. There's an operational community out there, the places like the Climate Prediction Center, which is one of the national centers of the National Weather Service. And there's also a lot of researchers that are working in this area, both in the United States and at other numerical modeling centers around the world. So it's a growth area. It's kind of a new challenge. I'm sure that Ben Kirtman could probably speak more to that, but it's one of the areas. It's a forecasting problem, and so it's completely appropriate for this journal. And yet, traditionally, there haven't been a lot of seasonal prediction papers published in weather and forecasting. But as this area is growing, and now with Ben Kirtman joining our editorial board, I think we're well positioned to handle these papers. And that was one of the motivations for identifying this paper, because it I think illustrates the way forecasting at these timescales works.
When you started, Gary, when did you start with as chief editor of WAF? I'm trying to remember. It was just not too long ago, right? It's a couple of years ago.
Yeah, I think it was 2 years ago. In 2017, I took over from Paul Markowski.
And at that time, how frequent were the seasonal forecasting papers in WAF?
Well, we were starting to see some of them. I think there's a bit of a gap in the AMS journals. Journal of Climate would be a possible area, but they're really focusing more on processes and not as much on forecasting and forecasting verification. So I think there was a bit of a gap, and we were getting some papers in the seasonal prediction realm. And that was when, as chief editor, I started thinking, maybe we need to add editorial expertise in this area. We did have some papers where it was suggested they transfer to weather and forecasting, and some of the authors said, well, who is the editor that would handle our paper? And now that we have Ben on board, I think we have a great answer to that question. I think that's helping to increase the number of submissions in this area.
Of course, you also had a great answer in Brian. So I'm kind of curious because Ben is on the board now. Obviously, you can't assign it to Ben, but you have some other people who obviously knew something in this area as well. You've strengthened the area tremendously by adding Ben. But Brian, what was your background in seasonal forecasting coming into?
Yeah, not very strong. So my research interests are all in short-term prediction, so maybe out to just 2-3 days time. So when I got this paper from Gary, my first thought was, oh boy, I hope I know enough to be able to handle this one, both that it was seasonal, but also waves in the title. So that was a really interesting aspect. But when Gary hands the papers down, I read through them, and it was really, you have these aspects that I thought might be a little bit beyond what I could do in terms of seasonal prediction and the waves aspect. But then you realize that all the methodology was very similar to what I do in terms of verification. And it was interesting to me. So it worked out. And like Gary said, with a emerging kind of area like this, it has to kind of go to somebody, and we trying to build that area up. So I was happy to handle it, and I was a little nervous at first, but I think it worked out.
What would you say were the biggest challenges, though, in handling this paper, since it was a little different, but also it looks to me like quite a big step in terms of forecasting waves out 3-4 months. Would you say 4 months ultimately? Is that right?
Yeah, I think Ben could talk or speak to the details more, but yeah, it was essentially a seasonal prediction. I think the wintertime, if I recall correctly, Ben, correct me if I'm wrong, but you're looking at wintertime prediction and the correlation between predicting waves and how it was controlled by the NAO primarily. But yeah, I mean, these were all, things I knew about on the periphery of my knowledge, but certainly not something I specialized in. So one of the challenges was actually finding the right reviewers. Usually when a lot of the papers that Gary passes to me are kind of more in my wheelhouse. And so I have an idea of who I'm going to ask, just usually when I see the title. But this was a lot more difficult to find that. But the AMS database and, just the kind of social network, it makes it easy to kind of get out and find people I think that will be good reviewers. And like I said, I think in the end, it worked out very well. It was very, nothing crazy about the review process with this one.
How would you say that, I guess this is a question for both Brian and Gary, but I'm just kind of curious, how does the mandate or the scope of WAF, being that journal that bridges the valley of death, so to speak, between research and applications, how does that affect the review process or the way you think about who you're writing for?
Well, I guess I'll go first, and then please chime in, Brian.
Mm-hmm.
For me, depending on the paper, I try to get a diverse set of reviewers. And so, for example, I might try to get somebody who's more on the operational applied side, and then maybe somebody who's more on the kind of theoretical and research side. So I try to actually bridge that valley with my selection of reviewers to get those diverse perspectives, to make sure that I'm not biasing the review process, towards my academic colleagues who might be somewhat less sympathetic to some of the operational pressures that the forecasters have to deal with. But of course, I'm kind of looking at research-oriented operational people, the kind of people that are at the national centers or at laboratories, because a lot of operational forecasters are just too busy and not really necessarily interested in doing reviews. But so people that are working in those labs and centers, they're generally well aware of the operational pressures, but also well aware of the latest techniques and research.
Yeah, I would say so. I've really tried to engage some of these science and operations officers at the National Weather Service offices, and that has been really eye-opening. I think the really heavy operational perspectives are a lot different from some of the academic perspectives. So getting a kind of a diverse set of reviewers that can add both these perspectives is a key goal for me when I'm looking for reviewers. But that bridging that gap was a challenge. I think when I've been an editor at WEF for I think about 4.5 years now, so I hadn't really thought about getting that operational perspective in there until I was maybe a year in. But really making it a priority, I think, helped quite a bit, because it's one of the main goals of WAF is to get these techniques that are being produced in the research side into operations. So I think that has helped. And I think a lot of the operational folks at National Weather Service, they weren't frequent reviewers. So a lot of them, it was almost begging them to do, some of their first reviews for an AMS journal, which was another really interesting aspect.
I guess, Ben, you're the one who had to look at all those reviews and try and do something with them.
Yeah.
How did that variety of perspectives affect you when you're working with the reviews?
Well, I always try to put on the hat that the reviewers are trying to make for a better paper. Sometimes it seems a little harsh and the comments are tough to deal with. You can't help but take them a little bit personally. But in the end, I try to, look at every comment of every reviewer as either identifying something that we did that was unclear and difficult to understand, or they're trying to actually help me make the paper better. In either case, addressing those comments makes for a better paper. So for me, I actually really appreciate the review process as getting independent eyes on the paper. And other than extremely rare cases, I've found that the reviewers are very helpful.
Were there any surprises or changes that you weren't necessarily anticipating in the review process as you went with this paper?
There's always a surprise. We probably had a little too much detail in this in the first go round, some extraneous detail, and I think the reviewers sort of nudged us to improve the readability of the paper in that regard, and perhaps some of the nitty-gritty detail wasn't necessary for a full understanding of what we did and why we did it. And I'm, as a scientist, I'm always surprised when people ask me to remove detail, but I think in this case, it was a good comment. I think it makes the paper more accessible to a wider range of audience.
I think that's an interesting thing, that more detail is sometimes bad for communicating what you're trying to get across, especially in a paper where you never know what detail might be interesting or important to somebody in the audience. So that's an interesting balance that you're trying to strike there, it seems like. And I would say, actually, particularly in this paper, which if anyone out there hasn't read it yet, I think it's really interesting because you're pulling in so many different scales of motion, really, to predict waves and wave fields over a vast ocean over a long time frame. and you're going everywhere from, you got El Nino, North Atlantic oscillation, sudden stratospheric warming. I mean, you got all this different stuff that comes into this paper.
Yes.
Just to get down to the winds, which ultimately affect very local decisions about, say, I guess maybe you can explain just in terms of what sort of offshore and other uses this type of forecast could have. It seems could be very local.
One of the things that I think we're learning in the subseasonal and the seasonal prediction community is some of the best metrics in a general sense of skill are in how the forecasts are actually used to make decisions. And so application models, in this case, we used WaveWatch 3 to predict sea state, are a great way to really get at whether your seasonal forecast is producing something that can underpin important decisions. And so the basic idea here is we want to use the seasonal forecast to predict the details of sea state, waves, wave period, significant wave height, those types of things. So people can think about ship routing a few months in advance, oil exploration, think about risk assessments and things like that, which are really the point of subseasonal and seasonal forecasting. And so just using this application model puts the forecast through a tighter test, or a higher bar in terms of how well we're performing. It's often easy to say, oh, okay, we did a pretty good job of predicting the winds. They look pretty good. But when you put them in an application model and ask, well, what happened with the waves? That's a real hard test. And so I've become much more enamored with thinking about designing metrics and ways to evaluate seasonal forecasts that are driven by ultimately how people are going to use that information to make decisions. And this is just one example of that.
In the weather forecasting community, there's a famous paper by Murphy in which he says, forecasts by themselves have no intrinsic value. And what Ben was just saying, I think, is, that's about that gap between the research and the operational communities. I think researchers a lot of times say, hey, we've got this great thing here. It's an exciting research discovery and isn't that valuable. But in terms of forecasting, it really only acquires value when someone can do something useful with it. And I think that I only really fairly recently have come to appreciate that. And I think it sounds like Ben has had that same epiphany in terms of thinking about where the value really comes from when doing this kind of research.
In this particular paper, you're basically you're showing, Ben, that there's some skill in what you're doing, which implies that there's going to be some use for this information. But how do you design your research and choose topics like that, and you know that you're going to get to a result that might be useful like that? How do those considerations play a part in where you're going with your research?
My sense is the best way to do that is to engage the community or an individual that has to make a decision based on the information at the outset of the work. And so this particular project has a long history in coming from the U.S. Navy, remarkably enough, in that they were interested in wondering how they could use these multi-model forecasts to think about ship routing associated with deployments and operations. And so it all became sort of an outgrowth of that, and thinking about how can we provide better information to Navy planners. And so it was some early discussions with them of what they think is important that really sort of developed, okay, let's try an application model that will predict a sea state. So it was actually that interaction with a particular community that was thinking about using this for actual decisions that drove that. And what would make this, follow on to this study, or maybe even make this better, would be continued interaction, so that it would actually be used and for decisions. And then they would tell us, if you looked at the forecast this way, would it provide better information for me? And then we can, reevaluate. And so if we had an interactive process, I think between the forecast provider and the forecast user, we would even sort of open new lines of investigation, new science that could be done. So I'm really become quite enamored with interacting with the people that need to make decisions.
I noticed that ONR, the Naval Research Office, is mentioned as a funder, but you're going beyond just the idea of funding from the Navy. You're talking about, I guess, reaching out to operational people in the Navy itself.
That's right. We communicated with folks at the Monterey Naval Research Laboratory to really sort of think about precisely what the operational naval forecaster uses to help, guide deployments. What they currently use in terms of climate information to try to drive, provide good information for operational planning. And we felt that this approach would be a big improvement on, or at least another way of looking at things. And in our our goal would be to someday get this into the suite of systems that they actually use to inform. So what happens is if someone needs to plan an operational mission, they contact Fleet Numeric and NRL in Monterey and say, look, this is the mission we're planning, and we need some climatological guidance on what's happening. And we found out what fields they're interested in, and what kind of time horizons they look at, and the issues that they're faced with, the challenge. And so that's how we sort of set up the design of this set of experiments. Ultimately, that interaction is challenging, and we still have a ways to go to try to get them to actually use the information. But at least that, what is the operational forecaster being asked to provide to the decision makers was driving what we did.
One of the key things here is that you weren't just looking at predicting on a seasonal scale. You were looking, and you say this first study, looking at seasonal ocean wave forecasts using a multi-model ensemble. So what made that possible now that wasn't possible before? I mean, there were a number of different modeling schemes that are used here, much all operational, right? They're from operational centers, and there were 7 of them. Is that right?
That's right. So one of the we had just because of the driving force behind this was this potential use in naval operational planning. One question we had to grapple with is, how would you do this so that if it proves to be useful, it could actually be used the next day? So we wanted to make sure we only included models that are committed to making forecasts in real time, all the time, on time, every time. That sort of NOAA mantra about forecasts. And so we leveraged both the EuroSIP project, which is a European project in seasonal forecasting, and then of course the North American multi-model ensemble, which is now an officially NOAA operational product that actually we're the scientific lead for at the University of Miami. And so we brought those two systems together specifically because those forecasts are made available in real time all the time. If the Navy was interested, or some cruise line or some tanker ship company was interested in these sea state forecasts or oil exploration or whatever, we could effectively make sure those forecasts were available in real time. So that was a definitive decision in the experimental design here.
And I guess the experiment basically steps through, like step 1, predict the winds at 10 meter height, and then step 2 is predicting the waves. And you made an interesting finding that, I mean, it makes sense that the models that do well with the winds would do well with the waves, or vice versa. They don't do well with the waves. But that's not the whole connection there. Like, there's more than just getting the winds right. What are the variations in these models that make for such a nice ensemble, and then also why some of them don't necessarily translate into good wave prediction?
Right. So one of the models, and it's the model. Interestingly enough, it's the model that we run at the University of Miami as part of this project. But one of the models that doesn't particularly do all that well at predicting significant wave height, predicting the sea state, is the CCSM-4. But what's interesting is it does comparable to other models in terms of the 10-meter winds. It does okay. And so the conclusion you come to is that it really does matter precisely where the model does well, and in precisely how. And the application tool is identifying that for you. So yeah, it does. I could easily walk away and say, oh yeah, I can predict the winds enough to predict waves. But it's not until you actually test it in this application model that you actually identify that the whole story is not just the skill score for the winds. The whole story is exactly where. Or is it in the right place? Is it in the wave generation region? There's some really important details, and some models do better at getting the winds right in the right place for the right spatial structure and scale, and they ultimately give better sea state predictions. And so that's the real advantage of these application models, is it really filters it down to what's important.
Running an experiment like this, or making any kind of prediction on a seasonal scale, or you're not really predicting on a specific day the sea state will be a certain thing
That's right.
or look like a certain way. But you're averaging and showing a probability distribution.
It's averages over months. In this case, actually, it's a seasonal average, but we're certainly looking at shifts in the probability of the seasonal averages. So, because we have 7 models and 10 realizations from every model, there are 70 versions for any particular forecast. There are 70 versions of the world, and so we can sort of plot all of that and look at that total distribution and ask where did nature fall in that distribution. And so if nature falls within that distribution that all the models produce, we tend to think we're doing a pretty good job. If nature falls outside that distribution, then there's something seriously wrong with our models. And there are times and places where the nature is doing something very different than all of our models think are even possible. And so we want to accurately represent the chances of a particular variability, a particular phenomenon actually happening. And so that's why we're using models that have the best way to think about it is they each do a different job of capturing the full range of possible outcomes. And so when you put them all together, then you get a better representation of the full range of possible outcomes. And we can use that to make a better forecast of what are the chances of extreme sea state in 2017 or 2022 or whatever it is. So it's from that probabilistic perspective that we hope we're providing better information.
Probabilistic results sound much more complicated, much more for the esoteric journal, but in a way it's the opposite, that's more useful for a lot of people, right? I mean, is that what you're finding?
Oh, that's what I'm finding. It turns out, actually, I think, most people don't think in terms of probabilities. There is a culturalization that has to happen to get people to think in probabilities. But when you talk to people that they actually have to make decisions, they intuitively do this all the time. It's just part of their intuition. And because there are multiple inputs that are used to form their decision process, not any particular one. And so they're basically forming probabilities in their own head when they try to take into account all the various inputs. And so when you interact with people that are making decisions and you start thinking about providing that information in a probabilistic way, it's actually much easier for them to use it, much more granularity. A good example is they're going to lose enormous amounts of money if an extreme event happens. And so if I can say the probability of that extreme event went from, a climatological value, say of 4%, and it went up to say 8%, that's going to have a big effect on their decision process because the chances of that very extreme event has just doubled. So their financial risk, if they don't take that into account, has increased significantly. And so people that are, making these decisions are quite capable of dealing with probabilities and that there's a shift in the probability and that's something they should take into account.
Gary, does that sound like more and more the kind of paper that WAF is getting, where the consideration of how to report the results or even just using ensembles to generate that sort of statistics is more common because those are the kinds of results that are useful?
Yeah, I think in the short-term weather forecasting community, ensemble and probabilistic prediction is becoming better established. And in fact, earlier we were talking about, which editor to handle this paper. Brian Ancell is a leader in this area with ensemble prediction and kind of probabilistic forecasting methods. And that was the thing that caught my eye about this paper that made me think that Brian would be a really good editor to handle it because of his expertise. And it's interesting reading the paper and thinking about these things, how the same problems carry over, the culturalization that Ben mentioned, trying to sort of probe the minds of the people that are making the forecasts and realizing that they really are thinking more probabilistically than maybe they realized. But these are the same challenges that we have for short-term weather prediction. And again, that's kind of a connection I think I saw between Brian's expertise and the subject of this paper.
Yeah, and I'm glad you gave me the paper, Gary, because it was nice to see some of that ensemble stuff in the more seasonal realm as well. As Gary mentioned, it has been a challenge getting some of that probabilistic stuff across. I think it surprises me sometimes that a lot of the forecasters I work with, it's very easy to get, of course they want probabilities, but then a lot of other ones don't. And so that's it has been a challenge to work with probabilities and getting that kind of culture was mentioned, kind of that probabilistic culture in place. I mean, it really is all about probability. We have imperfect models and imperfect initial conditions. So if we don't characterize that uncertainty, it's taking away valuable information, the kind of stuff Ben was talking about, that I think end users who have specific applications, they understand it and need to use that a little bit more, especially with financial risk and stuff like that. But then again, there's the general public, and I think that's a big kind of sociological aspect is, what do different users want in a forecast? So kind of going down a tangent, but that's it's a challenge for sure. But like I said, Gary, I'm happy Gary gave me the paper, and I do ensemble work, so it was very exciting to me to handle it.
Well, I find it really interesting that every journal has a culture, and that the culture of weather and forecasting as a journal is quite diverse, actually, even though it sounds weather analysis, it sounds very specific. But Ben, you come from a lot of climate papers in your background, a lot of papers that might not have fit into WAF, back then, but now you've got a real solid home, even as an editor there. It shows a little bit of the evolution of the culture as well, based on a lot of these shared issues. And so I really appreciate you guys explaining a little bit more about weather analysis and forecasting, and just in general. Great paper. I hope everybody gets a chance to read Ray and Ben's paper. And thanks again.
Thank you.
Thank you.
Yeah, thanks for inviting us to have this discussion.
And that's going to do it for this episode of AMS on the Air. If you don't follow us on social media, you can follow us at AMS on the Air on Twitter and Facebook and Instagram. And if you haven't heard, AMS has recently reduced its journal page charge fees by 17%, which means it's more affordable than ever to publish with weather and forecasting or any of our highly respected journals. Visit ametsoc.org/submit to learn more. That's ametsoc.org/submit to learn more. Thanks again for listening, and we'll see you next time on the air.